Hello everyone, this is Chandana from the Department of Electronics, Gopal Swami PU College. In today's session, I will be dealing with the second chapter, that is transistor biasing. In the last few sessions, I have completed the chapter 1, that is field effect transistor. So those who have not seen those videos, please do visit that channel, that is gsipucmysuru, and watch for those videos. So in today's session, I will be just doing the basics of this transistor what we have already studied in our first year. So in the first chapter, that is in the first session of field effect transistor, I told you the difference between the FET and the BJT. BJT in the sense bipolar junction transistor. So I told you the difference between those two, and now in this session I will be telling the basics of transistor. So what is this transistor? A transistor is a 3-terminal bipolar current conducting device. 3-terminal, it will be having 3 terminals. It is a bipolar device and a current conducting semiconductor device. Why it is called as bipolar? Because both the majority and minority charge carriers are responsible for current conduction, hence the name bipolar. And there are 2 types of transistor, that is NPN transistor and PNP transistor. There are 2 types, NPN transistor and PNP transistor. What is this NPN transistor? In the NPN transistor, P region or the P-type semiconductor is sandwiched between 2 N-type semiconductors. In between 2 N-type semiconductors, there is another region which is a P-type. And in the PNP type of transistor, there is a N region which is sandwiched between 2 P regions. So these are the 2 types of transistor, that is NPN and PNP transistors. Coming to the symbols of these transistors, before that let me draw this, where P region is sandwiched between 2 N regions. So P region is sandwiched between 2 N region. If you look at this diagram, the P region is very small compared to these 2 N region. This terminal is called as a base terminal. This terminal is called as the emitter, and this is called as a collector. This transistor is nothing but 2 diodes which are connected back to back. We have already seen in the first year what is a diode and how many terminals are there in a diode anta nodide. Diode is having 2 terminals, one is called as the anode, the other one is called as a cathode. So here this transistor is nothing but 2 diodes. Diode anta it is having only 1 junction, but here it is, we are having 2 junctions. This is 1 junction and this is another junction. So this transistor is nothing but a 3-terminal 2 junction bipolar current conducting device. So how do we tell that this a transistor is a 2 diode which is connected back to back? If I consider this NP separately, NP, and again if this P is divided into 2 parts, this is another P and this is another N. So here I will be having 3 terminals. This is emitter, base, and this is collector. Symbolic representation of diode is this. This is the P type, this is the N type. So coming to this part, here the diode is connected like this, right? And here PN. So these 2 are connected like this to give a common terminal what is called as the base. This is the emitter and this is the collector. So transistor is nothing but 2 diodes which are connected back to back. This is N, P, this is P and this is N. So this is an NPN transistor where the P layer or the P region size is very small compared to these 2 regions, that is emitter region and the collector region. Emitter is a heavily doped region. What do you mean by heavily doped region? More number of impurity atoms will be added for this emitter region. Base is a lightly doped region, whereas collector is a moderately doped region. I mean to tell that the number of impurity atoms added for this collector is more compared to the base region but less compared to the emitter region. Coming to the size or coming to the region, collector is having a large size or collector region is more compared to the emitter and the base. Emitter is medium in region, medium in size, collector is large in size and base is small in size. So emitter is heavily doped, moderately sized, collector is large in size but moderately doped, whereas base is small in size. This is NPN transistor. Coming to the symbolic representation of a transistor is like this. This is the base, emitter and the collector, and the arrow mark is towards the emitter. This is a NPN transistor. So this is all about NPN transistor. If I come across this PNP transistor, PNP transistor is nothing but one N region is sandwiched between two P regions. So one N region will be sandwiched between two P regions. Again, this is the emitter terminal, this is the base, whereas this is a collector terminal. As usual, emitter is heavily doped but medium in size. Collector is moderately doped but large in size, whereas coming to this base, it is narrow in size and it is lightly doped. So this is the PNP transistor, and the symbolic representation of this transistor is, this is the emitter, this is the base, emitter and the collector, and the arrow mark is pointing away from the emitter terminal. This is the symbolic representation of PNP transistor. Coming to the diode representation of this is P type, N type, and this is the emitter terminal, whereas coming to this N type, this is P type, N type, this is the terminal what is called as the base, and this is the collector terminal. So this is the two diodes which are connected back to back to give a PNP transistor. So what is a transistor now? Let me brief it. Transistor is a three terminal. Which are those three terminals? Exactly, emitter, base and the collector, bipolar device. Bipolar in the sense both the majority charge carriers as well as the minority charge carriers are responsible for the current conduction, and two junction device. It is having two junctions. In between this NP, I will be having one junction, and between this PN, I will be having another junction. So it is a three terminal, two junction, bipolar current conducting device. Clear? We now know there are three terminals in a transistor. One is the emitter, the second one is the base, and the third one is a collector. So emitter is nothing but, let us try to understand the functions of these three terminals. Emitter is nothing but a terminal which gives the charge carriers or which provides the charge carriers to flow from emitter to the base region, because in a transistor first comes, this is the emitter, this is the base and this is the collector. If I consider any type NPN adru agli to PNP naru agli. So emitter is nothing but a terminal which provides the charge carriers to flow into the base region, and base is nothing but the terminal which controls the flow of charge carriers from the emitter terminal to the collector terminal, whereas collector is nothing but the terminal which collects the charge carriers that can either be the majority charge carriers or the minority charge carriers. So these are the functions of these three terminals, that is the emitter, base and the collector. I told you that the emitter is heavily doped, whereas collector is moderately doped and base is lightly doped. So ಅದನ್ನ ನಾವು ಸಿಂಬಾಲಿಕ್ ಆಗಿ ಪಿಕ್ಟೋರಿಯಲ್ ರೆಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, ದಿಸ್ ಇಸ್ ದ ಎಮಿಟರ್, this is the base, whereas this is the collector. Collector is large. So this is NPN transistor. So in the first session itself, in the first chapter itself, I told you, whenever a semiconductor device is heavily doped, the width of the depletion region will be small. Whenever the semiconductor device is lightly doped, the width of the depletion region is very, very large. So P region or the base terminal or the base region is a lightly doped region. Lightly doped ಆಗಿರೋದ್ರಿಂದ the width of the depletion region will be very, very large compared to other two terminals. ಸೊ ಇದನ್ನ ನಾನು ಪಿ ಸೈಡ್ ನಲ್ಲಿರುವಂಥ ಡಿಪ್ಲೀಷನ್ ರೀಜನ್ ಅಂತ ಯಾಕೆ ಎರಡು ಬರ್ದಿದೆ, ಬಿಕಾಸ್ ಐ ಆಮ್ ಹ್ಯಾವಿಂಗ್ ಟೂ ಜಂಕ್ಷನ್ಸ್ ಓವರ್ ಹಿಯರ್. ಎನ್ is connected to the emitter terminal ಆಗಿರೋದ್ರಿಂದ emitter is heavily doped ಆಗಿರೋದ್ರಿಂದ the width of the depletion region will be very, very small. So this is the depletion region of this particular junction, and the collector terminal is moderately doped ಆಗಿರೋದ್ರಿಂದ the width of the depletion region will be slightly less than this width and slightly more than this width. I can write it like this. So whenever the semiconductor device or whenever p-type or n-type is lightly doped, the width of the depletion region will be large. Whenever that region is heavily doped, the width of the depletion region will be small. Yake? Because more number of free charge carriers will be here. More number of free charge carriers will be here. As soon as I apply the biasing condition, not all of the electrons or not all of the free charge carriers can cross the junction, because they are majority in number. Heavily doped ಆಗಿರೋದ್ರಿಂದ more number of free electrons will be generated in this particular region. So the width of the depletion region is small compared to other two regions. So this is all about the depletion region in terms of doping levels. These transistors are mainly used in two different applications. One is it is used as a switch, the other one it is used as an amplifier. So what is this switch? Switch is having only two states, right? Switch ಅಂತಂದ್ರೆ ಏನು ಕೆಲಸ ಮಾಡುತ್ತೆ, ಒಂದು ಆನ್ ಮಾಡುತ್ತೆ ಇಲ್ಲ ಅಂದ್ರೆ ಒಂದು ಆಫ್ ಮಾಡುತ್ತೆ. So this switch, this transistor can be used as a switch which is working as an on switch or as an off switch, which can work as an on switch or as an off switch. Coming to this amplifier, amplifier antandre in the introduction part itself I told you, amplifier is nothing but a circuit which strengthens the weak signal. Strengthens the weak signal anta helidre, if I am having a signal something like this, I am having a sinusoidal signal, if I give this as input for one amplifier circuit, the output of that amplifier circuit will be like this. It is being strengthened. It strengthens the weak signal or it boosts the input signal anta helbodu. So why is this amplifier used? Usually like loudspeaker set anta helidaga we will be having an amplifier over there. Yakella amplifier irutte? The person whoever is speaking with the help of a mic, that has to be given to a loudspeaker. ಯಾವುದೋ ಒಂದು ಪಬ್ಲಿಕ್ ಅಡ್ರೆಸ್ಸಿಂಗ್ ಫಂಕ್ಷನ್ ಅಂತ ತಿಳ್ಕೊಂಡ್ರೆ, ಸೊ ಮೈಕಲ್ಲಿ ಅವ್ರು ಏನು ಮಾತಾಡ್ತಿರ್ತಾರೆ, that signal has to be transferred to the loudspeaker. ಆ ಮೈಕನ್ನು ಜನರೇಟ್ ಮಾಡುವಂಥ ಸಿಗ್ನಲ್ will be very, very small. That cannot be directly given to a loudspeaker. So what we have to do, we are going to give that signal to a circuit what is called as an amplifier, and that amplifier will give an output which is boosted up or which has strengthened the input signal. So ee transistor do important or the major application is amplifier. So transistor can perform two different operations. One is as a switch, the other one is as an amplifier. Now let us try to understand how the transistor can be used as a switch anta nod. I know that the transistor will be having how many terminals? 3 terminals. One is the emitter, base and the collector. If I consider NPN type of transistor. So diodes will be having 2 terminals, right? But here, ಎರಡು diodes I am connected back to back ಅಂತ ಹೇಳಿದ್ರೆ totally I have to get 4 different terminals. But here one of the terminal will be made common. Here base is ಕಾಮನ್ ಟರ್ಮಿನಲ್. ಇಲ್ಲಿ ಬೇಸನ್ನ ನಾನು ಕಾಮನ್ ಆಗಿ ತಗೊಂಡಿದ್ದೀನಿ. ದಟ್ configuration will be called as common base configuration. I can also make emitter as the common point, CE configuration, that is common emitter configuration, and even the collector can be made common for both input and output. So antadana we are going to call it as the common collector configuration. In these particular examples I have taken the first one, that is the common base configurations. Input signal na nan apply madbeku antare minimum I need 2 terminals, output na togobeku andre again I need 2 different terminals. So one of these 3 terminals will be made common, with the help of which I am going to apply both input and take the output between those 2 terminals. So if I want this transistor to operate as a switch, I have to connect the input between these 2 terminals and take output between these 2 terminals. Biasing antandre eno? Biasing is nothing but applying external voltage. So here we have to connect the external DC source which biases the transistor. So what kind of biasing it has to be done? Biasing nalli eradu type of biasing ide. One is the forward biasing, the other one is a reverse biasing. Forward biasing anta helidre P type of the semiconductor. If I consider a diode, this is the P type and this is the N type, right? P type of the diode is connected to the positive terminal and the N type is connected to negative terminal. This is the forward biasing. Reverse biasing anta helidre N type will be connected to positive terminal. If I consider the same diagram, ide thara consider madana. P type will be connected to negative terminal, whereas the N type will be connected to positive terminal. This is the reverse biasing condition. So here switch age nanu connection ಮಾಡಬೇಕು. I want to use this transistor as a switch ಅಂತ ಹೇಳಿದ್ರೆ I have to connect a biasing, or I have to connect a voltage source between emitter and the base and between base and the collector. Switch ali, as I already told you, it will be having 2 different positions. One is on, the other one is off. So if I want this transistor to operate as an off switch, both the junctions, this is the nothing but a junction, right? This junction, both of these junctions has to be reverse biased. Reverse bias anta hedre P type must be connected to negative terminal, N type must be connected to positive terminal. This is the positive and this is the negative. So idondu junction na already connect ಮಾಡಿ ಆಯ್ತು. If I consider this particular junction, P type must be connected to negative, whereas N type must be connected to positive terminal. So this type of biasing makes the transistor to work as a switch which is working in the off state. ಅದೇ ಥರ ಆನ್ ಸ್ಟೇಟ್ ಬೇಕು ಅಂತ ಹೇಳಿದ್ರೆ, I mean to say, if I want to use a transistor in the on condition, again let me take the same example, that is NPN transistor. This is the emitter terminal, this is the collector, whereas this is the base. Both the junctions has to be forward biased. P type must be connected to positive, N type must be connected to negative terminal in order to make this as a forward biasing condition. And again, even this junction has to be forward biased in the sense P type must be connected to positive, whereas N must be connected to negative. Both will be forward biased. So if both the junctions are forward biased, then this circuit will be operating as a switch which is in the on state. So this is all about the switch. Other application what I told you is the transistor can be used as an amplifier. Amplifier agi use ಮಾಡಬೇಕು ಅಂತಂದ್ರೆ how the connection must be. So let me consider the same transistor, that is NPN transistor. Clear? So this is the emitter terminal, this is the base terminal, whereas this is the collector terminal. The junction which is present between the emitter and the base is called as emitter base junction, and the junction which is present between the base and the collector is called as collector base junction. So if I want this transistor to work as an amplifier, I have to connect this emitter base junction in the forward biasing condition. Forward bias anta helidre P type is connected to positive terminal of the battery, N type is connected to negative terminal of the battery, whereas the collector base junction must be reverse biased. Reverse biased anta helidre P type is connected to negative, N type is connected to positive terminal. This circuit will help the transistor to work as an amplifier circuit. So as I told you, transistor is having two different applications. One is switch, the other one is amplifier. Switch alli ಎರಡು condition irutte ಅಥವಾ ಎರಡು state irutte. One is the on switch, the other one is the off switch. So if I want the transistor to work as an on switch, both the junctions has to be ಎಂತ biasing ಮಾಡಬೇಕು, forward bias. If I want the transistor to work as an off switch, I want both the junctions to be connected in the reverse biasing condition. Coming for the amplifier, the emitter base junction has to be forward biased, whereas the collector base junction must be reverse biased to make our transistor to work as an amplifier. So this is all about the applications, major applications. Adre hege amplifier, how the transistor will be used as an amplifier, that will be seeing in detail in the next chapter. So this is all about the basics of applications. So now let us see the characteristics of this transistor. In the first chapter itself I told you that characteristics is very important. Why is this important? Because whenever I want to use any device in any of the circuit, I have to know the characteristics. I have to know the behavior of that particular device. So for different voltage conditions, how that device will be working or how that device will be behaving, that is very important before using that device in any of the applications. So now let us see the characteristics of the transistors. So there are two types of characteristics. One is the input characteristic, the other one is output characteristics. Let me draw a simple diagram which is used in order to draw the characteristics. So let me consider an NPN transistor. NPN ಅಂತ ಹೇಳಿದಾಗ arrow mark will be pointing towards the emitter terminal. So this is the emitter, this is the base and this is the collector terminal. So here I will be using a resistor which is called as RB, and here a voltage source which is connected in this particular manner, and here again I will be using another resistor which is called as RC and a voltage source which is connected in this particular manner. Let me call this as VCC and this as VBB. Clear? Here this is the input side and this is the output side. The voltage between the base and the emitter is called as VBE. The voltage between the collector and the emitter will be VCE. In order to measure the currents, let us use an ammeter over here. This is positive terminal, this is negative terminal, and again here ammeter which is connected in this particular manner. So let us try to understand what is the input characteristics. Input characteristics are nothing but a set of curves which gives the relationship between this current will be named as IB, that is the base current, whereas this is the collector current. So input characteristics is nothing but a graph which shows the set of curves between the emitter to base voltage and the base current, keeping VCE, that is collector to emitter voltage, constant. So here on the x axis we will be marking VBE, and here on the y axis we will be marking IB, keeping what? VCE constant. So we are going to get a graph like this. So this is the input characteristics. Coming to the output characteristics, again it is nothing but a graph which gives the relationship between VCE, that is collector to emitter voltage, and the collector current, keeping the base current constant. So VCE will be plotted on the x-axis, IC will be plotted on the y-axis, and we will be getting a different curves, a set of curves for different IB values. We consider this as IB equals 0, idana IB1, IB2, itara bere IB values ke we are going to get a set of curves. And the region which lies between IB equal to 0, our region we are going to call it as the cut-off region. Cut-off region anta helidre, a transistor is working as a switch which is in the off condition. Next, this region will be called as a saturation region. This region is called as a saturation region, during which the transistor will be acting like a switch in the on condition, and this straight line where the current is almost maintaining a constant value, that region is called as the active region, in which the transistor will be acting like a amplifier. So these are the three different regions which is very much essential in order to understand the transistor application. One is the cutoff region. Cutoff region is nothing but a region which lies below IB equals 0. The other one is the saturation region, which is almost linear. The last one is the active region. So this is the characteristics of a transistor. It is of two types. One is the input characteristics, the other one is output characteristics. VBE and VCE are nothing but the voltmeters what we are going to use. So how to vary this VBE and node on IB in the sense? For the input characteristics, I told you we are going to maintain VCE constant. So hege madodu adanna? With the help of this VCC, with the help of this voltage source, we are going to set VCE to some value, and we keep on varying this VBB for different values of VBE. Other corresponding IB value ಏನು ಬರುತ್ತೆ ಅದನ್ನು ಬರ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. Say for example, first ಇದನ್ನ ವೇರಿ ಮಾಡಿಕೊಂಡು VB ನ 0.1 volts ಬರೋ ಹಾಗೆ ಸೆಟ್ ಮಾಡ್ತೀವಿ. At this 0.1 volts, what is the value of IB? ಅದನ್ನ ನೋಟ್ ಡೌನ್ ಮಾಡ್ಕೊಳ್ತಾ ಹೋಗ್ತೀವಿ. ಪ್ಲಾಟ್ ಟ್ಯಾಬ್ಯುಲರ್ ಕಾಲಮ್ ತರ ಪ್ಲಾಟ್ ಮಾಡ್ತಾ ಹೋಗ್ತೀವಿ. Next I am going to set this 2.2 volts. That corresponding IB value will be recorded. Next it will be set 2.3 volts. ಈ ತರ for different values of VBE, we are going to make a note of IB. Similarly, for the output characteristics, we are going to set this IB value as constant. We are going to vary this VBB and set the IB value to some value, some constant value. Later on we will vary this VCC such that VCE will be varied in steps. ಒಂದೊಂದು ಬೇರೆ ಬೇರೆ values ಗೆ ನಾವು change ಮಾಡ್ತೀವಿ, and that corresponding IC value will be noted down. Then we are going to plot a graph like this. So this is all about the basics of this transistor. Hello everyone, here is a small try to introduce you to one of the basic electronic component at the end of my every session. However basic, these components play critical roles in today's technology. It has shaped the world as we know it. Because of these tiny pieces of metal and silicon, our world's technology is changing a long way even for today. Whether it's building cities, taking us to the moon, or sending a text. It really is amazing if this try can help you a bit. Since today is our first session of this type, let me try to tell you what is electronics. Electronics is derived from the word electron mechanics, which means study of the behavior of an electron under different conditions applied electric field. The device which controls the flow of electrons is called electronic device. These devices are the main building blocks of electronic circuits. The motion of electrons through a conductor gives us electric current. This electric current can be produced with the help of batteries and generators. Electronics have various branches which include digital electronics, analog electronics, microelectronics, and nanoelectronics. Now let us see the history of electronics. Diode vacuum tube was the first electronic component invented by J.A. Fleming, that is Sir John Ambrose Fleming. Later, Lee D. Forrest developed a triode, a 3-element vacuum tube capable of voltage amplification. Triode consists of 3 electrodes, cathode element, anode plate, and control grid used as an amplifier, as an oscillator, and in electric circuits. In 1947, Bell Laboratories developed the first transistor based on the research of Shockley, Bardeen, and Breton. In 1959, Jack Kilby of Texas Instruments developed the first integrated circuit, which is usually known as IC. Now let us see some of the advantages of electronics. Electronic devices are playing a major role in our everyday life. The various electronic devices we use in our daily life include computer, mobile phones, ATM, pen drive, television, digital camera, etc. On a whole, our day starts with electronics and ends with electronics. I'm concluding this part of the session at this stage, hoping that you're going to like it. In the next session, I'll be coming with one new electronic component. Thank you. In the next session, I'll be telling you the very important point, what is called as the Q point. Q point andandre eno? What is the operating region, or it is also called as the quiescent point. So what exactly is that Q point? How this Q point is playing a major role for selecting this transistor in different applications ಅನ್ನೋದನ್ನ next session ಅಲ್ಲಿ ನೋಡ್ತೀನಿ. So I'll be coming soon with the next video, that is the session 2 of the same chapter. Until then, take care, bye bye.